Okay, students, let's start our today's topic. Okay, so our today's chapter, the name of the chapter is ordinary differential equations. Ordinary differential equation. As you guys already know that what is an equation, right? So in a function, let's say we have a function y is equals to f of x, right? And in y is equal to f of x is called independent, sorry, x is called dependent variable, dependent variable, while y is called independent variable, right? X is called independent variable, while y is known as dependent variable. So how, if we plot a graph, then at different values of x, you will have a unique value of y. Not all the time you will have a unique value. Sometimes it corresponding to x value, it have two values. As we already know that in the quadratic equation, sometimes you will get y is equals to plus minus 2, right? Plus minus n, right? It can have two values at the same value of x. So such kind of when we add the differential things in here, like for example, we write what we can say that n dy by dx plus n squared d squared y by dx squared is equals to 0. So such type of equations is known as ordinary differential equations. Okay, so in which there is only one independent variable and one dependent variable, right? Such kind of equations is known as ordinary differential equation. Sometimes it happens like in our equation we have like more than one dependent and more than one independent variable. For example, we can have dy by dx, or we can have dy by dz, or dy by maybe something du, right? If these are involved in our equation more than one, then we will call it partially differential equations. So for this particular chapter, we will focus only for ordinary differential equation, which is can be denoted by ODE, ordinary differential equations. So there are various methods to solve the ordinary differential equations. So in this chapter, first we will have a Picard method. Then we will have Euler's method. And then we will cover Rangi-Gupta method. We're gonna cover these three. Okay, first, second, and the third. Okay, let's start our question number one with of the ordinary differential equation. and with the Picard method. We will start with this one. Okay, so in this one, again, you will be given one equation. There will be equation, and corresponding initial value condition. It will be given to you. Okay, so we will start our question number one with the Picard method. So the for the solution of Picard method, the equation is given by yn plus 1 is equals to y naught plus integral x naught x f of x y dx. This is n, x n into dx. This is the formula that we will apply for the Picard method. Okay, so let's solve one question. Okay, we can solve in here. So in the question, it is given that dy by dx is equals to x plus y squared, and initial value condition is y0 is equals to 0. This is initial value condition. We can say that initial value problem or initial value condition, and this is your equation. Okay, so sometimes they also ask you to find y 1.5 or 0.5 at the end of the question. They might ask you to find this one. So first we will solve our ordinary differential equation by Picard method. And other thing is that it is called iterative method. It is also called iterative method, in which we will solve our equation as per the requirement of our question. So in this question, they say that solve up to 3 iteration. So again, what will be given? We will be given one equation, its corresponding initial value condition, and then it will be given that the iteration. These three things will be given to solve your ordinary differential equation by Picard method. Okay, so let's start from here. I will change the color, let's say. Okay, so for example, in here, let's write the equation, this one, the Picard equation in a proper form. So we can write it y n plus 1 is equals to y naught plus integral x naught x, and fx, this fx is always here, this one. Okay, so we can write it x plus y squared into n, this is n, right, and dx. So if you put n is equals to 0, right, if you put n is equal to 0, what the equation it will be y1 is equals to y0 plus integral x naught x into x plus y0 squared dx. Right? This will be our equation. And we already know that at this one, this is initial value condition. So y0 is equals to 0 and then x0 is equals to 0. Because this one, the value of the function of the value of y at x is equals to this one, right? So this one is x, this one will be x naught, and this one will be corresponding y naught, right? So we will put the corresponding value in here, and then is 0 plus integral x naught is equal to 0 to x, right, into x plus what is value of y naught? Y naught is equals to 0, right, into dx. Further, if we solve it, it will be equals to, I will solve it in here. Okay, so it will be equals to 0 plus integral 0 to x dx. So it will be 0 plus x squared by 2 integral 0 to x. So once we put 0 and then x, it will be equal to x squared by 2. So this one will be value of y1. Okay. So next we have to find the value of y2. Right? Again, write the formula yn plus 1 is equals to y naught plus integral x naught into x, and then we have the formula x plus y and raised to power 2 dx, right? Put n is equals to 1. It will be equals to y2 is equals to, we already have y naught, 0 plus integral x naught is equals to 0 and x, and put the value, the x, it will be same. Now what is then it is equal to y n is equal by 1 squared dx. Here we already know, we calculated y1 is equal to x squared by 2. Here y1 is equal to x squared by 2, right? Put value, then our question will be y2 is equals to 0 plus integral 0 to x into what we can say that x plus x squared by 2 into dx. It was x squared, and then y2 is equals to, I'm gonna remove this one. It will be equals to, we can say that 0 to x plus 0 to x squared by 2 dx. It will be equal to x squared by 2 plus it will be equals to it will be equal to x cube 3 by 3. X3 by what? 2 plus 1. Is it right? Can you calculate, any one of you, please? Can you make sure that it is correct? Okay. Okay, so I think there is one thing like it was squared, right? Actually, it was squared. It is square value y1 squared, right? So we have to put square here as well. So once we raise this one, okay. So now we can write it again. So it is x4. So it can be x, sorry, it can be x5 by 5, x5 by 5. This will be your y2. Okay, so y2 will be, yes, x by 20. Okay, again, let me see. Okay, is x 20. Yes, we have to multiply by 4 as well. It will be equals to 20. x5 by integral x5 or x4 by 4 is the dx. It will be equals to x4 plus 1 into 4 and integral 1 by 4. Yeah, no, 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 no. Integral, I believe that integral is like we add 1 and then plus 1. It is not correct. This one is not correct. x5, it is not correct. What's the error? Sure, okay, wait. So is expression 1 by 4 integral. x5 since its integral is no, its derivative. Its derivative should be x. For example, if we take x5 by 20, the derivative is power में से एक कम. Okay, so this one is correct. So it will be equals to 20. It will be x by 5 by 20. Okay, great. So this one will be your answer. Or okay, this is answer for y2, and the last, if we put n is equals to 2, then it will be y3. Y3 will be equals to y naught plus integral x naught into x plus yn is equals to yn, y if will be equals to 2, y2 squared into dx, right? Or we can write it x cube is equals to y naught plus integral x naught into x plus y2 is equals to y2 is our y2 is equals to x squared by 2 plus x 5 by 20 and raised to power 2 into dx, right? And now y3 will be equals to, let's put the value 0. It's already 0, so we will not write it because its value is 0. So we can write it x naught is equals to 0 to x, right? And then integral inside the integral x plus x squared, it is squared, so it will be equals to, if we open it, it will be equals to, let me, okay, so it will be squared x 4 by 4 plus square 5 x 10 by is 40 20 squared. What is the value of 20 squared? 400, right? And plus 2 into a and b. It will be x7 over 40. Is it correct? Can anyone please confirm me? Into dx. Because this one, let's say this is a and this is b. So we're gonna put a squared, a plus b squared is equal to a squared plus b squared plus 2ab. We're gonna put this formula, right? So in here, a was like x by 2, so it will be equals to x4 by 4 plus x5, 5x10 by 20 squared was 400 plus 2, a was x4, oh sorry, a was x2 by x2 by 2 into x5 by 20. So x4 by 4 plus x10 by 400 plus 2 is cancelled with this one. So we can write it x7 by 20. Right? Is it clear to everyone? Okay, so I'm gonna remove this one so we will have enough space to solve it. So we will solve it by, let's just write it 20 and just remove this one. Okay, so write y3 is equals to, we can write a x squared by 2 plus, can anyone tell me this one? What will be the value of this one? It will be equals to x 5 by 20. This one will be x 11 by, what will be this value? X 11 by 44. And the last one will be x 8 by 56, x 8 by 7 into 141, 160. Okay. So this is your y3. So we already have y3. So this is the end of our question. Okay. So at the end of the question, if they ask you find y 0.1, so it means you need x, you put 0.1. So y 0.1 will be equals to 0.1 squared by 2 plus 0.1 raised to power 5 by 20 plus 0.1 raised to power 11 by 4400 plus 0.1 divided by 160. This is raised to power 8. And then y 0.1. Calculate, please, and tell me the answer. What is this answer? So the answer is 5.00 into 10 raised to power minus 3. This will be okay. So I hope this thing is clear to everyone. So let's solve another problem. Then we will. So in other problem, they say solve by Picard method up to fourth order of initial value problem y dash is plus y is equals to e raised to power x at y naught is equals to 0. Okay, so this is your problem. And then let's move on to the solution. So first, let's try to simplify our this equation. We can write it that this equation as dy by dx plus y is equals to e raised to power x, or we can say that dy by dx is equals to e power x minus y, right? Because we have to use this particular formula, So in this particular formula, we need the form of dy by dx. Okay, so let's put the value of the Picard equation. Picard equation is given by yn plus 1 is equals to y naught plus integral x0 x into x comma yn dx, right? So put n is equals to 0. Our equation will become y1 is equals to y naught. What is the value of y naught in here? It is again 0. This is y naught. this is x naught, right? So we will put this one and plus x naught is equal to 0 to x, and this value is dy by dx, so we can put it ex minus y. This should be equals to minus y and minus y, that's it, and dx, right? So this one should be equals to yn, so y naught. So y1 will be equals to integral, this is 0, so I will remove it, 0 to x, and this is y naught is also 0, so we will put ex dx. So what is the value in here? You can say that integral of ex is equals to what? It is, I think, integral of ex is also ex, right? Y1 will be ex, and then 0 to x. And then we put ex minus e power 0. So e power 0 is equals to 1, right? So we can say that y1 is equals to ex minus 1, right? And then, okay, so now we have y1 is equal to ex minus 1. So let's go with the y2. y2 will be equals to, and now we have to put n is equals to 1, then it will be y2. So it will be equals to, y2 will be equals to y naught 0 plus integral x naught x into what is your value in here. This value will be equals to ex minus y1 dx, right? It will be like this one, but we already have y1, so we're gonna put it in here. So y2 will be equal to 0 plus integral, this is x naught is 0 to x e power x minus y1. y1 is equals to e power x, and if it is e power x minus plus 1, right, and dx, it will be cancelled out, and then y2 will be equals to 0 to x dx, so it will be equals to x plus c, or that's it. Okay, so this one was your y1, this is your y2. Okay, and now what we will go here. Okay, so now put n is equals to 2. Let me change the color. Okay, so it will be equals to y3 is equals to 0 plus x naught x integral of it was ex minus y2 into dx. So y3 will be equals to 0 plus 0 to x into ex minus, what was y2? y2 is your x, right? is x dx. So put y3 is equals to 0 plus e power x over e power x integral e power x into integral of, okay, that's it. Maybe we need to 0 to x minus integration of x squared by 2, 0 x, right? So once we put the value in here, so our answer will be equals to y2 will be equals to e power x minus 1 minus x squared by 2. This one will be e power x minus 1, and this is x minus x squared by 2. Okay, so this one is your y2, and let's move on. N is equals to put n is equals to 3. Put n is equals to 3 to get the y4. Y4 will be equals to 0, so y naught plus integral x naught into x into what is the value? What was the value? Dy by dx. It was ex minus y1 minus y3 d. And we already have y. This one was y3. We put this one. Okay, yes, it was y3. So it is 0 plus integral of 0 to x into ex minus y3. Y3 was ex minus 1 minus x squared by 2 dx. It is cancelled out, and then you will have 0 to x. You can say minus 1 and minus 0 to x into x squared by 2 dx, right? And then we will put the value in here. So what will be the value? Okay, this one, I think this one is minus, it should be plus, right? So this one is cancelled, so it is plus, this one is plus as well. And then finally, we will have integral x plus x cube over 6, right? X cube over 6. Okay, so this one will be y4. So that's your answer. So this is answer. If they ask you that find, let's say, y 0.2, then just put the value in here. So this will be your final answer. Is it clear to everyone? Let me know if you have any questions so we can talk more about this question. Okay, then let's take 5 minute break and then we will solve another question of the same method, Picard method, and then we will end the class and we will have the other two in our next week. We will have Okay, students, let's start our another example and then we will end the class. Where is the, okay. So our next question is, solve dy by dx is equals to 1 plus x y with x naught is equal to 0, y naught is equals to 0 up to third approximation. Okay, so let's try to solve this one using the Picard method. Okay, as it is already given, dy by dx is equals to 1 plus xy, which is equals to f of x, y, right? So our formula is yn plus 1 is equals to y naught plus integral x naught into x. So we're gonna put it in here, 1 plus x y is equals to n, so dx, right? So in here, if we put n is equals to 0, then we're gonna have y1 is equals to 0 plus integral 0 to x 1 plus x, because y naught is equals to 0. This one will be equals to y naught and y naught is equal to 0. So okay, then let's just write multiplied by y naught dx. Then y1 is equal to 0 plus integral 0 x. This is equal to 0. So our equation will become x dx, 1 dx. y1 will be equals to x, right? It will be x only. And this one will be your y1. And then we will have another question, another y2, which will be equals to y naught plus integral 0 to x 1 plus x y1 into dx. And then we can write it in 0 plus integral 0 to x 1 plus x into what is y1? y1 is x, so x into x is equals to x squared, right? Dx. And then what will be the integral y2 is equals to 0 plus 0 to x dx plus integral 0 to x squared dx. So what will be the answer? Anyone? Okay, x plus x cube over x plus x cube over 3. This one will be your y2. And then let's move on to, okay, so now put n is equals to 2 to find that y3. So y3 will be equals to 0. Actually, it's it is y0 plus integral x is 0 to x into 1 plus x and y2 dx, right? So y3 will be equals to 0 plus integral 0 to x, and then it is equal to 1 plus x into y was x plus x cube over 3 dx, right? So what we're gonna do, y3 is equals to integral 0 to x, so dx, right, plus integral of 0 to x. So we're gonna multiply it inside. So it's gonna be x multiplied by this one. It will be x squared, right? X squared dx plus integral 0 to x, x4 over x4 over 3 dx, right? So it will be your x plus it will be your x squared by 2 plus, oh sorry, x cubed by 3, right? X cubed by 3. It will be x cubed by 3 plus x 5 over 5 multiplied by 3, 15. It will be 15 plus c. Okay. So this one will be your y3. And the finally, let's go with the y4. So y4 will be equals to, okay, so put n is equals to 3 to get y4. Y4, let's solve it in the other paper. So y4 will be equals to y0 plus integral x, so x0 into x into 1 plus x y3 dx. Y0 0, so 0 plus integral 0 x into 1 plus x y cube is given by x plus y cube x cube, sorry, it was x first and then it was x plus x cube by 3 plus x5 by 15 dx. 0 to x and then dx plus integral 0 to x, so it will be x dx plus this one will be 0 to x, x4 over 3 dx plus x6 over 15 dx integral 0 to x. So now we will have 0 plus x squared. Sorry, this one will be x. It will not be squared. X plus x cubed by 3 plus x 5 by 15 plus x 7 by 7 into 15. So 7 by 15 is 106. 105, yeah. Okay, so this one will be your answer. So this one will be by 4. So this is your final question. So we solved today about the three numericals from Picard method, and I already told you that what is the ordinary differential equations. So we have ordinary differential equation in which there is only one dependent and one independent variables. If there is more than one, then we call it the partially differential equation. So the solution of ordinary differential equation, we have the first method we talk about is the Picard method, and then we will talk about the Euler's method and the then Runge-Kutta method in our next class. Okay, so for exam point of view, we will have the exam on 20th, the next Saturday. We will have exam on next Saturday in the same time from 6 to 7:30. Okay, this will be our exam time. So we still have a lecture day on Friday, right? So we will have one more lecture on 19, and then the exam will be on 20. Okay, so any question regarding to this topic? Okay, so no question. So let's end the class, and let's see you again next week. And meanwhile, please prepare your exam as well. I will upload your syllabus in the Canvas, and then yes, Saturday will be your final exam. Saturday next week, the same time. Next week, same time. Yeah. Like 6 to 7:30, because we have our class at 6 to 7:30. So in this time we will have a exam. Okay, so I will just save it. And I will send you the whiteboard of the today's class. And for now, I will say goodbye to you guys. Okay, please take care and see you next week. Bye bye.